This question here says that an elevator can go up or down with the uniform speed when its weight is balanced with the tension of its cable. So we have been given two statements. We have to find which of them are true, right? So first statement, so both of them are simple application of Newton's law. Let's see statement number one. So we know that by basic Newton's law, if there's a body and these are, let's say, forces acting F1, F2, and there can be many. So F external is equal to mass and acceleration of the center of mass of the body. This is what is Newton's second law, right? The external force is equal to mass of the body or a system of particles, whatever you can say, times the acceleration of the center of mass of the system, right? So the first case here, the first statement here is saying that the elevator can go up or down with uniform speed. Uniform speed means acceleration is zero, right? For anything, if it is going with a uniform speed, that means acceleration is zero, right? So weight is balanced with the tension of the cable. Yeah, obviously, because whatever it be, if it is going with up or down, whatever direction it is going with a uniform speed, that means acceleration is zero. That means the tension that is pulling it upwards and the weight, right? Weight that is pulling the elevator downwards, both of them have to be equal and balancing each other out, right? So that the net external force, F external, is zero. Then only it can go with a fixed speed or constant speed when the acceleration is zero. So this is simple application of Newton's second law, right? Fine. Now let's see the second statement. Force exerted by the floor of an elevator on the foot of a person standing on it is more than his or her weight when the elevator goes down with increasing speed. So what is the question? What is the meaning of the statement? Again, the same thing, right? Again, the same fact you have to use, that if F external is there, there has to be some acceleration. The question is saying that the elevator is going down with an increasing speed. That means the elevator along with the person inside is accelerated downwards, right? The speed is increasing in the downward direction. That means the elevator and the person inside, both of them are accelerating downward, right? So now if I take the person separately and make the free body diagram of the person here, okay? What are the forces acting? One is the normal force that the floor of the elevator is applying on the person, and the other one is going to be the weight, right? mg. These are the two forces acting on the person. These are the only two forces, right? If the person is accelerated downward, that means obviously the weight is going to be more than the normal force, right? The force in the downward direction here is mg, right? And in the upward direction is normal force. If it has to have an acceleration in the downward direction, obviously the weight has to be more than the normal force, right? So there will be a feeling of weightlessness, right? The push from the floor is going to be lesser than the weight. So that's why there is going to be a feeling of weightlessness to the person, right? So the statement says here, force exerted by the floor of an elevator on the foot of a person, that is the normal force we are talking about, is more than his or her weight. That is obviously not true. We have seen here. That's not true. The weight is going to be more than the normal force. Then only the person can be accelerated downwards, right? So the statement 2 is obviously not correct here. Statement 1 is right. So which is the matching option? Statement 1 is true. Statement 2 is false. Option number 2 becomes the correct answer for this question. Okay. Thank you.